Well, hi, good morning. Thanks so much for joining me in my shop here on the last day of October, Halloween. It is. And so today I'm going to be doing the alignment on the radio itself. But we should take a peek at the cabinet here so I have a notion as to what needs to be done. And obviously there's the cleanup and polishing and stuff like that. But there are two lights in here. There's a light in this area and another one up here. This one, the red top filter's gone. There's a red filter here. And if we look inside, big sheet of asbestos on the bottom there, which I haven't done anything about. I may just leave this just as it is. Leave it alone. But you can see the wires are just kind of tucked away here. Let me pull them out if I can. One. Yeah, so two wires here, same thing on the other side. So somebody previously disconnected these wires from somewhere. Where? I don't know. Now the bulbs that are in here are the old style incandescent Christmas bulbs. So it wouldn't be too tough to restore this in such a way that when you plug in the radio or perhaps switch it on, the lights come on. I would think at that point I'd want to install a separate light switch to turn the lights on and off so you can have the lights on when the radio's not, because this is very decorative. I got to think about these things. That's why I wanted to take a peek at it. Look, it's got little portholes here. The light will come out. Cool, very cool. Okay, I'm going to sail this off to another spot in my shop. Now, so I have the alignment instructions for this. I'm going to follow them. I'm pretty sure it says inject the IF test frequency that's going to go through the two IF transformers into the grid of the first two. I believe that's what I read. So I'm going to review those, and we'll get busy. Oh, you know what I want to do? Yesterday when I worked on this radio, I took a moment where I determined a number of factors. Frequency the radio's tuned to, frequency of the local oscillator, bypassing frequency of the IF, which is supposed to be 460, I think, but in fact it looked like it's 440. Based on what I did. And you should be able to mix those numbers together and everything should add up. I'll put it that way. Everything should add up. But it didn't. It didn't yesterday. So I'm going to repeat that before I start the alignment process. And just because from what I understand about how these radios work, it's not possible for those numbers to add up. So something happened, and I just like to try it again and take a closer look at that. Okay, we'll just take a peek at the alignment instructions here. Precaution. If the signal generator is AC operated, and of course, I mean, how else would it be operated? By battery? I guess that's possible back then. Mine certainly is plugged in the wall. Use an isolating transformer between the power supply and the radio receiver power input. That's how my shop is set up, in fact. The use of an isolating capacitor is not recommended, as AC through the capacitor will introduce a hum, blah blah blah. So the deal here, connect an output meter across the voice coil. Now if you're using like a battery operated multimeter, there's not a lot of issues here, but if you're using the kind of meter I'm about to use, which is a 3-prong plugged meter, you'll see it in a second, it's a vintage vintage output meter. You need to follow these instructions or take other steps to be careful about what you're doing. But if you follow the instructions here, connect the output meter across the voice coil. I'll show you why they're suggesting that. So here's the schematic for the radio. Another alternative is to measure the voltage that's building up in the AVC circuit of the radio. and often you can pick that up right at the volume control. Where is the volume control? Here it is here. And in fact, the input side of this volume control has got the DC sitting on it that comes from the rectification of the output of the IF here, the AVC volt. You can monitor that. You can put a meter on there, a low impedance meter. You would not want to put it on the other side of this big resistor. This is bound to be a mega ohm or two. And putting the meter over here will probably disturb the circuit because the impedance of the meter is significant compared to the circuit. It will affect the circuit. But over here, they say, no, don't do any of that. Don't try to measure the AVC voltage. There's other reasons that's not the best way to do things, but it's effective. They wanted to hook up across the speaker. So you see the speaker voice coil is isolated by this transformer from the rest of the radio. So the whole issue with this radio in terms of safety and the like is because of this arrangement here in the power supply with no transformer. So depending upon which way you plug this into the wall, although in my case it's polarized, it can only go in one way, but that doesn't guarantee safety here. And considering whether the switch here is open or closed. But I don't know how, if somebody else put this cord on, I don't know what they did. We'll have to take a look at that in a minute. By hooking your meter up here, you're isolated away from the rest of the radio. So if your meter is like mine, plugged in the wall, it's an AC powered meter, and one lead to the meter is grounded. Now, I stick that grounded lead in this radio here, I'm going to have to be very, very careful. But if I stick it out here, I don't have to be careful at all. This is all isolated. That's the reason why they're telling you to put this on the speaker. The problem with putting it on the speaker is you have to listen to the speaker too. And so, like the volume can get fairly high while you're doing these things. That's the story there. Okay, so, and then we better read exactly where to connect it. I'm pretty sure they're saying connect it on this grid. Connect the input on this grid, which is pin number, I don't know, pin number could be 8, could be 6 here, not sure. I can find out though, easy enough. 12SA7. Let's read the instructions again. I think it's on the other page. Apply a signal to the converter grid through a 0.05 microfarad capacitor and align progressively the trimmers in the second and first IF transformers. Okay, and 460 is the number. So we need to put it on the converter grid. They're not telling you here what the number is. Couldn't read it on the thing, so I'll look in my book and find out. Okay, here's my book. 12SA7. Two types. It's a metal and a glass type. The GT is the glass type. I've got a metal one here. It's a metal type too. Look at the metal side of things. Metal type 12SA7. Okay, so we just need to look at this diagram, and we can see that the grid number 1 is on pin 5. Grid number 3, I think, is the one we're interested in. It's very hard to look at this. Pin number 8, there we are, G3. Pin number 8. So I think pin number 8 is where we want to inject our signal. Pin number 8. Okay, so we'll look in the radio here and see where pin number 8 is. A little more light on the situation here. Pin number 8. So 8 is this one with the green wire on it. The green wires often are indicating grid connections, although there's no guarantee. The wiring, the color of the wires doesn't guarantee much. I still haven't changed this capacitor. Oh yeah, let's keep going. Wait a minute, now I want to do that test. Well, I can do the test. I can do part of the test with the connection made right there. Let's do that. The test being measuring the factors that should all add up, which didn't add up yesterday. Now I got to think about this. So I have a ground lead here. Now let's check this out. before I go any further, because I'm not hooking it up. Well, this is supposed to be hooked up through. They didn't say what to do with the ground. So I'm looking in the radio at the chassis, and I'm looking to see how the chassis is connected. Okay, so here I found one connection. Let me point. I just don't like sticking my fingers in radios. Right here. This terminal is crimped. I can't think of the word. Hey, what's with me? Can't think of the word. Don't bend this, Jim. Careful. Riveted to the chassis. It's not the best way to do it, and they did not solder it. So often when a riveted ground connection is made in a radio like this, the manufacturer will solder it down to make it certain. And I found radios with trouble with exactly this kind of thing, these rivets. So, but that's the ground, and then the wire is, well, it's disappearing out onto the top. Where's it going? It's coming out on the top. It's coming over here to the antenna. Ooh, it's not quite what I expected. Let's follow the power cord. Power cord comes in. One side goes to the switch. Hopefully that's the hot side, the way they've done it. Because it has a polarized plug, every time it goes in the outlet, it's known which way it's going to be. And the larger spade is the ground, and the smaller spade is the hot side on the plug. So hopefully the hot side has gone to the switch. Pretty fancy knot he tied in here. This cord is plenty fine. It's a nicely done job, I think. But the only connection I see reaching the chassis is the one I found over here. I don't see anything else. Wait a minute now. So there's another terminal strip up here. How's that held in? So another thing worth looking at is how is the frame of the capacitor connected. It's just screwed right down onto the chassis. It's not it's not isolated in any way. It's worth just making notes of these sorts of things, especially when you're starting to hook up test equipment. Well, okay, so there's a ground right here. So this terminal is riveted, also riveted to the chassis. It's a great big 0.22, a 0.2 microfarad capacitor there. That's two connections onto the chassis now. One that's one basically is a wire going to the antenna. We got to look at that. So a lot of these radios, the antenna is actually an isolated coil on the back of the radio here. You can see it here, and it has, you know, the antenna wire hooked up to it, and the other side is going not to the B minus in the radio, but going somewhere else. Let's look on the schematic before I say too much here. See what it shows about this grounding situation. We need to get this sorted out before I start doing stuff. Okay, so if we look, there's a ground symbol there. This is a classic, and there's a ground symbol there. So let's start with the antenna. You can see the antenna is connected to the chassis. And the chassis, this represents the chassis in this case, is connected to the B minus line, or B minus line there, it says B minus, through a capacitor, C2, and a resistor. This is a classic way of doing this. So the idea here is the antenna feels the effect of a ground connection all the way out through the plug and into the hydro system. So it kind of has something to work against, if you like. And the way it transmits its signal into the radio is through this isolation transformer here, another transformer isolating away the antenna. Why do they do this? Well, I think they want to control impedances, and they want to reduce the impact of the variations in the antenna. Who knows what's going to be hooked up to the radio. They want to reduce the impact of that on the radio itself. So this technique allows the antenna signal to get through, but at the same time, I'd say desensitizes, that's a bad word, in my view anyway, makes it less critical what kind of antenna's out there in terms of disturbing the biasing and things like that in here. So there's a capacitor C20. C20, this is probably the capacitor, this is certainly the capacitor that's mounted right on the antenna. I wouldn't want this to be shorted. The radio would work fine if this is shorted, but you're gambling a little bit. The original plug was not polarized, so the gamble would be real. In this case, the gamble is what did the last guy do with this plug. Hopefully he hooked the hot wire to the switch. Doesn't make the radio safe. Makes it safe when it's turned off. With a unpolarized plug, it's a 50-50 gamble which way you plugged it in the outlet as to whether the switch is closed and it's safe, or open and it's safe, or closed and it's dangerous. So you got to read up on this. If you don't know what I'm talking about and you're fooling around with these radios, you need to find out about the hot chassis problem, which is basically what I'm sort of considering right now. So the idea here is if you didn't do this, then you would have a big sheet of metal, the chassis, kind of half wrapped around this radio. This great big piece of metal causes a number of problems. One is, it is an antenna of a sort, and it's going to pick up signals, not necessarily radio signals, but 60 cycles and stuff like that. Yeah, it'll pick up radio signals too. And potentially re-radiate that stuff into the very close components and wires in the radio. That's not going to be helpful. So you want to kind of drain that stuff out. And so that's what this idea is. You've taken the chassis and you're draining it back to the B minus. Why bother with these? Why not just hook it right up? When you hook it right up, you introduce a very serious hot chassis problem. There's a couple versions of the hot chassis thing. This is a warm chassis. Nobody uses that term, but there is some protection here. Even if you had an unpolarized plug, you plugged it in backwards. This is at 120 volts relative to ground. You're standing on the ground, and this chassis is only connected through this large resistor and a relatively small capacitor. So how much current can you draw? Enough to feel, but not enough to die. That's the theory. And why enough to feel? Well, they can't size these so big that in the end you can't feel the trickle charge, so you don't even know you're being electrocuted. Because if these get too big, if this gets too big and this gets too small, then they won't drain the signals out of the chassis. Another thing the chassis can do is it can transport signals through the radio. So if you haven't done this, a big chunk of metal sitting here up against the radio, you have some strong signals in here. The local oscillator is quite strong, and that local oscillator can work its way through the chassis and be picked up somewhere else. Or the output of the IF, which is also quite strong, and it's at radio frequency 460 kilohertz. It can get on the chassis, ride its way back to the front end, get back in the antenna, get back on the grids here, and come through again. And come through again is another way of saying oscillation. And you get, because this effect is under the control of the automatic volume control, the AVC voltage, often the radio will break into a motorboating pattern, in which you have a strong signal come through. A moment later you have strong AVC voltage, the signal is cut back, the AVC voltage fades out, the signal comes through again, AVC voltage builds up, the signal is cut back, and you get the motorboat kind of sound going on. So that's the whole deal of this. Now, do I have the story 100% right? Probably not. Good enough? Probably. Am I going to get a shock? No. Am I going to ruin my test equipment? No. If this were actually solidly connected, and that's a common thing too, you just hook it up solid, then you've got a red light radio for sure. You really need to understand what's going on. You might even want to put a voltmeter or something on the B minus to keep an eye on it, just in case you accidentally reverse the plug while you're fooling around and things go from one state to another. 120 volts will kill you under the right circumstances. So, I don't want the right circumstances here. Okay, that's enough talk. I don't like to lecture about safety because my own view is your safety is your business. I can't tell you enough here. I don't know what you're doing. I don't know who you are. So the most I'm going to do is tell you, read up on these things. Make sure you know about them before you start fooling around. You might think these little radios are safe and easy as opposed to the big honkers, the big old shortwave radios. The opposite is true. Big old radios are actually safer to work on than this guy. They don't have the hot chassis problem. They have a transformer here, and the bulk of the radio is pretty much isolated away from the power system. Pretty much, but not necessarily. Okay, enough lecturing. I think I'm ready here. We want to go on, what was the grid? Grid 8. Pin 8. Pin 8. That's an 8. Good. Okay, I didn't quite finish the story here. So I have to hook up my meter, the oscillator signal output wire. I got to drink more coffee here for sure. I got to figure out where to put the black wire, the ground wire. Should I put it on the chassis and then put the live wire, through a capacitor to the grid over here? And the answer is actually no. You should really put it right on this B minus line. So where can I do that? Easy place to find stuff usually is around the volume control, because one end is where the signal is coming out of the radio, the rectified signal, and the other end often is grounded. Not always. A lot of funny things go on in radios, but this one, if you track the other end of the volume control, there's a dot there, right there. There's a dot right there. It's hooked right up to B minus. So B minus is sitting on the bottom of the volume control. So that's a great place to ground it. Now, when I look at the volume control, how can I be sure which end I'm on? Well, this end has a resistor. Well, who knows what they're doing with these wires? I mean, it looks like this on the schematic, but in the radio, it can be done quite differently. Capacitor right across the volume control, that's not going to help me. Lead coming out of the can here going to the volume control would mark the top end. I want the bottom end. Okay, I think I can sort it out. Let's go take a look. Okay, so volume control here. There's the capacitor right across the volume control. This is big filter capacitor. The negative side is hooked to this one here, the negative side, and together they're hooked to here. I think that's marking the ground quite clearly. That's the volume control, the grounded end right there. So that's great. That's easy access. I can just take this. Now, before I make the radio's not on. Before I make this connection, I could take my finger. I would never do this, okay? But I could pretty much touch any place in the radio and not get a shock, because the radio is being fed through an isolation transformer. I would never do that. Might do it by accident. I would never do it on purpose, but I should be able to get away from it. It's like a bird on the wire thing. Well, why doesn't the bird get electrocuted? Well, it's only touching one wire. Talk to squirrels. Squirrels and power systems, by the way, you have a lot of these insulators. Squirrels and raccoons will stand at the bottom, maybe standing on the top of a transformer, and they'll reach up across the insulator, and that's the last thing they do. Boom! A lot of squirrels and raccoons meet their end that way. So I can put this here. I'm going to clip it right up here where I think it'll be fairly secure. And this guy, if you haven't noticed, I have a capacitor already sticking out here. So it's a little on the... Reduce the leverage. It's got way too long a lead sticking out. here. But that's okay. That's good enough. So that's the input to the grid, which is pin 8 on the 12SA7. Ground is done correctly. I gotta hook up, well, I might as well hook up this guy too. So why not do that? Okay. So that's an output meter. It has a scale in decibels. Decibels is a ratio, and there's no zero on the meter. Zero is always somewhere way over here. So you can see a zero sitting there for a voltage, but in terms of decibels, there's no zero on there. I want this to go on to the voice coil leads. I'll tip this up again and check those connections now that I've tipped it down. So putting on the voice coil. Now, according to the schematic, neither side of the voice coil is grounded. This is important enough to double check, to be absolutely sure that that's the case. Just only have to touch one lead to find out. Uh-oh. Hey, what's going on? So one of the leads over here, the reason I did that, one of the triggers for me was one of these wires is bare. One has got insulation on it, and the other one is bare. And that just suggests to me, hey, wait a minute. The other one's going right to the frame of the speaker. Wait a minute. Hold your horses. Everybody come to a stop. Let me switch to the, I have to. Okay, I'm going to switch to a different camera. We can get a little closer look in there. Okay, let's take a little closer look at the speaker. So there's one connection. You notice the wire has an insulating sleeve on it. It goes back to the transformer. This is the transformer right here. And if you look, the terminal is on a piece of cardboard, black cardboard. It's probably kind of flimsy. Ooh, it's pretty stiff. Well, you know, that feels like metal to me, actually. And it appears to be riveted into the speaker here, but I'm sure this is not conductive. When I touched this with my meter probe, I got a tone indicating a short. Well, the impedance of the speaker is very low, right? The resistance of the speaker winding is very low, 8 ohms or less. So either side is going to give me the impression that it's grounded. Only one side is grounded. This side is insulated. And the other side is a little hard to get a view of it here. It's kind of tucked away, but you can see it's a little out of focus, but you can see a copper wire coming up. And what's it doing on the end there? I think I can get in at it this way. There it is. It's soldered right to the frame of the speaker. The other part of this is the frame of the speaker is not in any way isolated from the chassis. Is that true? Is that true? Did I say that's not true? I'm pretty sure it's true here. Where is it? It's just sitting right on the chassis. So we got something here that's different than what is shown on the schematic, and the implications are significant enough that you got to be aware of this. So isn't that something? The schematic is misleading on this very important issue. So what it really boils down to now is so I've got the ground from the signal generator, tip the radio up, connected to the B minus here. If I take the ground from my meter, it should really go to the same place, the B minus. So you don't have two grounds in separate places in a radio. That's not good. It's the bird on the wire thing. You can stick one ground on anything with an isolated radio, like this is on my bench. That's a really slow progress today. Well, what to do about this? Well, I could revert to using the AVC voltage, which, considering the fact that the speaker is actually grounded, there's not much advantage to measuring it off the speaker. And I'm using a high impedance meter, it shouldn't disturb the AVC voltage if I pick it up in a area of the radio that has a low impedance available, not in the high impedance part of the grid circuit. So, okay, we're going to do that. So we go to the volume control again. And where'd you go, volume control? Up here. And so we realize that one side is B minus, but the other side is kind of way up in there. Oh, maybe it's on this wire. Maybe it's right there. I can go right there. Where this green capacitor is. What's this green capacitor size? Well, we may not know by looking at it. What size it is. It's a 600 volt capacitor. But that's probably, well, you know what? This is probably the center terminal, actually. The ground terminal is probably on that colored wire down there. The brownish wire is probably it. And looking with my eyes, I can usually see these things a little better than with the camera. But I think that's pretty certain of what it is. So this green wire. Well, we need more light. More light. Need more light. I'm taking my time with this because I'm guessing you might be new to this stuff and you may not be aware of some things. Look at a pretty sloppy soldering job right there, isn't it? I should have put, yeah, I won't go on about that. I do my own sloppy soldering, but clearly the green capacitor is on the center terminal and the brown wire, well, it seems to be going past. How can it go past? Well, something's got to come out of there, off that terminal. I think we just can't see how it's connected. It looks like nothing's connected to it. I can see the terminal. It looks like nothing's been soldered to it. Wait one cotton picking. Whoops. Man, I'm trying to erase that phrase from my life. I never use it except on these videos once in a while. I really feel bad about it because I can't seem to get it out of my head. Oh, it's something my mother said 10 times a day without understanding what that term is really referring to. You know, we're in Canada and there's no cotton here. Well, I can't see it. I cannot see it with the camera. I'm assuming you couldn't see it either. So I'll just look at it with my eyeballs. Again, the radio's not turned on. It's not even plugged in. Okay, so I can clearly see that that wire comes up and connects to the terminal. They just soldered it lower than that eye. And that wire, tracing it very carefully, comes to here. And here's a large resistor here. See red, green? So that's 2.2 megohms. That's a couple megohms here. So on one side it's lower impedance, and the other side is higher. So this is the ground to the meter. I'm going to put it here too. So both grounds are on the B minus. And then I'm going to take this, should I use a different meter for this? I think I'm going to use a different meter than the output meter. I'm going to change my mind here. I'm going to use this meter over here. Okay, bring this one up. Over here, good, because in this case I'm not reading output, I'm reading a voltage that's building up in the AVC circuit. Flip lead, please. So I like this other meter for doing that kind of reading. So this, you want to connect, where'd that 2.2, there it is there. There's the connection there. And I better take a closer look at that. These clip leads have a way of wandering. You don't want that to happen. I'm going to leave the radio up on its side. So looking again, we have the connection to the grid here is about to come off. Make a better connection. That's a little better. Okay. We made it to the point where we can start. I would expect the negative voltage to build up here. Here. And only when there's a signal coming through, a modulated signal. So luckily my big old signal generator there will do it. We're going to make this meter disappear because we're not going to use it. Ever wonder why they put the power cord on the top of an instrument like this? I believe it's exactly for this reason, because I keep it up on the shelf. So I'm able to bring it down and put it up. If it were on the back, it wouldn't make any difference, would it? Okay, so I don't know why they have it on the top. Why not on the back? Okay, anyway, up she goes. Well, coffee time. It's coffee time. Let's get this guy operating. I can leave it kind of warming up. And make sure everything's correct. Grounds are on correct. Black leads, red lead here, meter there, scale on minus 50 volts. It's not going to produce 50 volts there. Okay, let's switch on. Oh, plug in. We never did sort out for sure which way this plug has been done. Let's do that now. Let's do that right now before... One side is connected straight to the B minus, I believe. Switch is off. Switch is on. What's going on? Hello, hello. I'm making good contact here. So that's reading 173 ohms. Why is such a bad connection? 75 ohms. Why did I do this? It looks like it's reading through the capacitor. Let's do this a different way, because I'm not getting a good feeling out of this at all. Okay, so we follow the wire to the switch. We'll say which side of the plug is on the switch. The switch has to be off. Which side? This is the smooth side. Okay, so that's the live wire. Good. Live wire, live terminal, hooked up to the switch. That's the best arrangement you can do this way. Switch is open, the live wire just ends right here. Right there. No more. No, nothing else can make that sound. Very good. The fellow who put it in did the right thing. Doesn't guarantee safety. It makes things safer. And because you're going to put on a newer core, it's quite likely to be polarized. You've got to make a decision what you're going to do with one lead or the other. Okay, so we're good to go. Okay, is that off? Oh, I gotta plug it in. Now, I just went through this grounded thing, but I'm not plugging it into a grounded outlet. There's no ground on this at all. This is an isolation transformer, so perhaps that was an exercise that wasn't really needed. We are cooking here. So this connection onto the grid of the first two may cause radio effects. It may silence the radio, but we'll get around that. Here it comes. So the tone you barely hear, 400 hertz tone, is coming from the signal generator. Okay, put it up to 1,000. Hear it a little bit better. Now I'm going to vary the frequency here. You can watch it here and listen for when it gets loudest. Very clearly, it's right around 440, and it's supposed to be up here, 460. Okay, we can also check, see if the AVC voltage is showing up on the meter here. Make this a little more sensitive. And we're in the negative setting. The reason there's a negative voltage developing in the radio is because the engineers arranged the diode detector to produce a negative voltage. They could flip it around, it could produce a positive voltage. Positive voltage is not helpful. Negative voltage is very helpful. So it's a sneaky way to get a negative voltage that you can apply to grids and then, hey, the voltage varies with the strength of the signal. Automatic volume control. And why does varying the voltage on the grid of some of these tubes affect the radio's gain? Tubes are designed that way. They've figured out how to physically construct the grids and all that kind of stuff, so that as the voltage is driven more negative, the gain goes down on the tube. They're designed to do that. Okay, otherwise, whoever designed the tubes to do that first sold a lot of tubes. I think that's kind of the driver. So we see a level here, and I'm going to tune the radio. That won't make any difference. Well, get rid of the noise. Yeah, I had it tuned on a noisy spot. So we'll go to a quiet spot. All you hear what's happening there. So he's not making a good connection. Okay, I'm not going to worry about that just now. I want to know that the test setup works. So I'm going to change the frequency being sent to the radio from 440 to something else, and we should see the meter drop, basically. Here we go. Good. And if I put a much stronger signal in, wow, we got a big one there. Lovely. Okay, we're all set to change the alignment of the IF, but I wanted to do that study first. So I'm going to set up for that, and this guy should warm up a little bit before we start aligning it anyway. Good, coffee break time. Okay, lots of time has gone by. Let's just make sure what the IF frequency is. So I'm going to peak that meter by varying the get it right up to the top, and the answer is 441. So I'm going to write that down. 441. Now, got to change things a little bit. Do I have to? I don't really have to, actually, because I'm putting the signal right into the first radio, right on basically the antenna grid, sort of. So I can just feed in another test frequency. It doesn't have to be the IF frequency. We're going to feed in 1 million. 1 million. Okay. 1 million. The reason for using 1 million here is it's easy figuring for my poor little brain. Now we're going to tune the radio and try to pick it up. It's a pretty strong signal here. That's okay, we'll leave it like that. Whoops. The wheel is grounding out here. The ship is grounded. Phew. I don't like touching radios with both my hands. I don't like it. Ooh, what is that? Okay, something going on there. Let's turn it down, turn it down a bit, turn it down. Don't get it so loud. Okay. Tune the radio now. Come on, radio, tune. 1 million is right here. Okay, we'll watch the meter over yonder. There's a capacitor involved that's charging up, and so it causes almost like a delay in the meter versus where the knob is. So you gotta go a little slow. It's not really. I guess it is a delay. Okay, that's good. What do we got on the dial? The dial says a million, 10, a million. I think it's 1,020,000. 1020 on the dial. Next thing we need to do, I didn't set this up, we need to look at the local oscillator frequency using my SDR. So, okay, stop for a minute and get that going. Okay, what should the local oscillator be under these circumstances? So we're feeding in a 1 million signal. 1 million signal. And the local oscillator has to be of that frequency away from it. So we just add them together. See how easy the arithmetic is. Fantastic. So that's the local oscillator frequency. That's what it should be. 1441. In my world, it can't be anything other than this. Okay, now we're going to take a look at the SDR and find out if I've lost my mind or not. Or there we go. Okay, so we're looking at the SDR. I have the pickup coil in the area. There's a strong signal right here. This red line is the tuning of the SDR. It doesn't mean anything. I can move it around. So this frequency, well, I don't know. What I'm going to do is I'm going to tune the radio slightly and see if it wiggles. Okay, so you can see something going back and forth around 1450. Okay, so I have to tune the radio back in, exactly on. So I'm looking at that meter. There we are. Okay, so it's this yellow line right here. Frequency is 144, and we could make it 1 here and just fine. So there we are. So this time it worked out exactly as it should. It has to work out like this. I don't know what happened yesterday. Okay. Well, I'm actually ready now to align the radio. So we're going to change the frequency back to oh, that's kind of interesting. Can you hear that? That's interesting. Here we are again, 441, 442, same thing. Now we're going to want to tune it up to here. Here's the challenge. If I go up to 460, you can't hear anything. So I start adjusting the transformers and I can't hear it. I'm just shooting in the dark. I can boost the signal, maybe we'll hear it. Okay. So a very strong signal is making its way through there. Excellent. Now I need screwdriver to use. Usually do this with a metal screwdriver. These are capacitors, trimmers, capacitors that we're adjusting. And generally, the screwdriver won't affect it. But we will check. You need to keep your eye now on this meter. It's all about the meter. Getting it to come up. Start with the second IF first. And that would be that there. Something's loose in this radio. Could be a tube. So the reason to do the alignment at this point is to find out how well the radio works. It can't work well if the alignment's not right. Okay, so here we go. Down. Bring it up to a peak. This one too. This should make a big difference at some point. That's pretty big. It's that ADC capacitor that makes this tricky. So I'm going to turn the output down over here. Still hear it. I'm going to go on to this one here. Just checking the frequency we're using is 460. See, this was way off. Okay, and then this. Certainly when a radio is this far out, oh, what's happening here? So I could be shorting the screw top to the can. Let's try that. That can make a difference. There's something going on here. This is some kind of, doesn't make much difference. Yeah, there's definitely something clicking back and forth. Like that. Somewhere in this radio is a problem. A hard kind of problem to find. But we want to get it performing as well as we can at this point. So there we are. Now, it makes sense to turn this down and do them over again. Still on 460. Yeah, so because there's like two states, a stronger and a weaker state, I gotta pay close attention to what. I gotta pay close attention. So didn't need to adjust that much. That helped. Now this adjustment has a big bearing on the tone of the radio. And in some cases, when you peak these up perfectly, you actually end up with a bad tone, not much trouble coming out of the radio. So sometimes the last thing you want to do is tune in a station and then just adjust these a little bit to get the kind of tone you're looking for. Maybe. Okay, so the IF is peaked up at 460 where it is supposed to be. Now we need to do the two trimmers down here. I can't get at them with the radio the way it is. Flip the radio right over. Okay, but I'm not going to do that with the power on. Too many wires hanging out of it. Power off. A little warm. That's a great thing about doing this work in the winter. I heat my shop up a little bit. Okay. Now, put the power back on. And I think I'm going to go up, up, up. First thing we want to do is adjust the local oscillator properly. So what we know is the radio is now running with an IF at 460. Can't see it there. That's 460. Turn this down a bit. So we're going to write down 460 on my fantastic notepad here. I'm going to move the pointer seems to be accurate enough on the string. I'm not going to try moving it. So I'm going to put the pointer right on 1 million. Here. I will do that. Okay. There's 1 million. And we can't do this at 460. On the signal generator, we need to do this up at 1 million again. Everything working right, we would hear this right now. Something's not working right. So my guess is the local oscillator is not where it should be. It needs to be adjusted. Let's find out by looking at the SDR where it actually is. Okay, Mr. Local Oscillator. Now I'm going to wiggle the tuning so we can identify the oscillator line. Where are you? Oh, I moved the pickup coil away. Must put the pickup coil back. Where'd it go? There it is. So I'm putting the pickup coil just near the mixer tube, basically. Okay. Oh, something showed up right here. Well, now that is the signal from the signal generator. That's the 1 million signal from the signal generator. So 460 above it, right up in this area, probably this red line right here. It should be right at 460 though. Okay, so I'm going to wiggle the tuning again a little bit. Okay, there we see it. It is the red line. Now that is supposed to be at 460. Let me make sure now, because I retuned the radio, it's right on 1 million. Okay, it's right on 1 million. Now I'm going to adjust. I'm going to stop for a second and change my cameras around. Okay, so I've got the SDR up on the screen there so we can see it. A little small on the video, but it'll have to do. So we're going to hear the signal come out of the radio too, and also, what is that? Oh no! Shadow. What is it? It's raining outside now. You can't go out. You can't go out. English. No, you're not going there. So her English isn't all that good, and I think she's going to continue crying here. So just trying to get confused between the radio's whining and the cat's whining. Right, so we're going to adjust the local oscillator. Earlier I determined the smaller set of plates is the local oscillator. There's no surprise there. Do a little, does this make a difference? Nope, we'll get away with it. This is too small of a screwdriver. I want a bigger screwdriver. Get a better control over it. We want to turn the screw until we hear the tone. Which way? One way then the other. So I'm literally tuning the radio. Oh, you can see the local oscillator moving around. Okay, I'm watching the meter now, maximizing the meter. Here we are. What frequency is that? So I will click on it here on the SDR. And 1458. So 1460 is what I was looking for. 58, 60. Sounds like the same thing to me. Check the dial. Very carefully. It's right on the money. So the radio pointer is right on 1 million. The signal generator is, can you see it? It's doing 1 million. The IF was set to 460. This radio is fully aligned. Because of the SDR, it gives you a great opportunity to see the local oscillator frequency directly when you're doing this. So it gives you an opportunity to take a different approach at alignment. That's it, the radio's aligned, so now it's time to test it. So I'm going to turn it off. I disconnect all my equipment here. None of this should have caused the radio's tuning or alignment to be off now. Should be okay. We'll get this out of here. Should work exactly the same. And then we're going to try to, that's my pickup coil for the SDR, which I don't need. Put this here. A little radio. This is your chance to shine. Your chance to show off. Volume down, power on. What happened here? Did we succeed? So let's go see. Station right at 860 here. Could be a directional antenna issue. There it is. Unfortunately, there's a noise signal kind of right on top of it. Barely hear it though. So lots of radios will pick that signal up 860 quite nicely. Okay, 710. This is from a city a couple hundred or more kilometers from here. Some radios can pick it up here in my shop. Not this one. Although that might be it. So we're picking up the carrier but not being able to hear the modulation. Next one is 680, but there's noise. In my shop there's noise right at 680. Not doing well. 640 is the next likely candidate right there. Again, it sounds like the carrier's there. Nothing in it. Okay. The strongest station is at 590. Sports station. That's not 590, that's 610. Oh, no, 610 is the St. Catharines station. Not 710. Okay, so that could be St. Catharines. The city of St. Catharines. This should be the 590 here. Come on, guy. Doesn't look right. Can't really understand what they're saying. Oh, there we are. Sports. So this is 590 of showing up at 610. The main thing is it's showing up. Well, okay, so the radio's performance still isn't all that great. Maybe this is the way this radio works, this particular model, but maybe not. One thing I have not looked at yet is the tubes and a couple of capacitors that are left in there, old ones. It's probably worth looking at all these things, but not today. That'll be for tomorrow. So tomorrow will be tubes, last couple of capacitors. We'll make some voltage readings in here to see what voltages are on these tubes. We'll look around for anything that might be out of sorts, just not quite right. We'll look at the grid potential on the output tube, see that it's not gone positive. Something unfortunate's happening there. Oh, I was just putting the video together when I suddenly realized I forgot something here. I forgot to do the antenna trimmer. Okay, we might get a big boost out of this one. So I'm going to turn the set back on, and we're going to go after that. stronger. It really needs to be tightened down. $5.90. Not. $8.60. Well, let's just try backing that off just a little bit. There it is. It's a compromise issue here. Typically, I think this capacitor would be adjusted up at the top of the band with a signal from the signal generator. When I'm just using a station, the highest station I can use is 860. All the AM stuff around here, anyway, is down here. So really making the radio perform well up here is kind of a waste. It's got to perform well down here. So at this point, we've got it doing 860. 740. No. 710. 740 be up here maybe? No. 680. Well, we can do some more of this tomorrow. 590. So still able to pick up 590. Except for the terrible. What's that? Interference is causing that squeal. And just tighten this up a little bit. A lot. Well, I guess you got to make your choice. You want it to work better down here or better up here. The Astros approach in Game 2. Okay, well, thanks a lot for watching. And tomorrow, like I say, we'll go through the tubes and do that other stuff. Maybe we'll find some problems, and we'll probably get back to doing another alignment job on this radio before all is said and done. So thanks a lot for watching.